In this video, we're going to go over how to add and subtract when there are variables within the problem. So the first thing you want to do is we need to look at each one and see if we can simplify them. So if I look at 14, I know the only numbers that go into 14 are 7 and 2 and 1 and 14. So 14 does not simplify. But x to the third, if I remember, it's an odd number. Odd means you divide. So 3 divided by 2, 1.5. You take the whole number, that number comes out. So 3, 1 whole x, and the other x stays inside. All right, so that is what the first one is, simplified. For the second one, 243. If I try dividing by my perfect squares, if I divide by 81, I would see 81 times 3. And I know the square root of 81 is 9. The square root of 3 is just 3. So I've simplified the 243 part, but I also need to simplify the x to the fourth. X to the fourth, 4 is even. Remember, you just divide by 2 again. 4 divided by 2. We get 2. So we're going to bring 2 of them outside. Just move this 9 over a little bit. Flip it. Just move it over. All right, and I'm going to bring the 2 x's out. But that's just the value that is inside the radical. We need to remember that there is this 9x in front. And to do that, we're just going to multiply by 9x, because remember, when it's right next to it, it means to multiply. We're going to focus on just what's outside of the radical. Outsides multiply with outsides. So 9 times 9 is 81. X times x squared is x to the third. And we just bring that square root of 3 down. So that is our simplified version for this middle term. Just highlight them so we don't lose them. And then we're going to go to the next row. In the next problem, I have 56. If I try to think of some perfect squares that are less than 56, I got 4. 56 divided by 4 is 14. Let me see if 16 works. 16 doesn't work. So let me try doing this as the square root of 14 and the square root of 4. Because when I divided by 4, I got 14. 4, I know breaks is 2 is its square root. And the 14, as we said earlier, the only numbers that go into 14 are 7 and 2 and 1 and 14. So the numerical part is going to break down to 2 square root 14. Now, again, I look at this x to the third. We've already done the same thing in the first term. X to the third, if you divide by 2, you're going to bring 1 outside, and 1 stays in. Right? Again, now I need to remember I need to multiply by this 2 that's sitting outside, and I get 4x, square root 14x. I'll highlight that so that we see it a little bit easier. And then we get to the last term. And the very last term is just the square root of 75. When I think of 75, I know 25 goes into it. That's a perfect square. 25 times 3. Square root of 25 is 5. So 5 square root 3. Right, so I've simplified each term here. And now I just want to rewrite the problem so that I can see everything together. So 3 square root 14x plus 81 x to the third square root 3 minus, and we're just taking the signs that are here, minus 4x square root 14x plus 5 square root 3. All right, to write this in standard form, my focus is going to be on the exponents that are outside of the radicals, and I want to go in descending order. So I'm going to look for the greatest exponent that I see, and I see this x to the third outside. When we are trying to combine radicals, we look at their square root symbol. So I had square root 3 here, and I also have a square root 3 here. For this particular problem, though, there's nothing that I can do with those because I cannot add 81x to the third and 5. It goes back to, our normal addition rules. I can't add something that has a variable with something that does not. So while they have that common square root 3, in this problem, can't do anything with that. So I'm just going to write both of them down. And then my focus is going to be on these other two. And you can see they both have the square root of 14x. And they both have an x outside. One has a 3x, one has a 4x. So those are truly like terms. I can combine those. 3x minus 4x is negative 1x. You could write negative 1 if you want, or you could just write minus, and we bring the 14x along, the square root of 14x. Again, you could write this 1 here in front of it if you really like, but in math, we usually try to only write what is necessary. And we know 1 times 14, the square root of 14x, is still the same thing as the square root of 14x. So in this problem, you needed to simplify each of the individual pieces. You needed to multiply by the coefficients or the values that were outside of the radical, and then combine what you could.